Alright, hi year 11s, this is Mr. Lim here again, and this is our final video on materials and separation techniques, called separation techniques. Duh. Alright, so we're going to learn about how the various separation techniques can be used, and generally if you learn that, you can work out how to separate stuff. Right, so because mixtures, and we're talking about separating mixtures here, are not chemically combined, they can be separated by their physical properties, which means that, whatever the physical properties of each component part, we can use those to separate them. This includes physical size, mass, density, boiling point, and solubility. All right, so let's have a look. Okay, so particle size. Easiest way to get rid of stuff is to filter it. Okay, so we're using a physical barrier with pores or holes which allow small particles to pass through. That's these little blue ones, right? Whilst larger particles, which are larger than the pores, like these green ones and yellow ones, they have to remain on the other side. All right, so filters can come with different size pores for different separating abilities, as well as different flow speeds. All right, so generally we talk about it in chemistry in terms of filter paper, but lots of different things are filters, like sieves and chicken wire. All of those things have different size pores to allow different things in. Right, so even chicken wire is technically a filter. It's just a filter for very, very large things. Right. Mass spectro. So mass spectro we've already gone through, but we're using the physical mass of the different isotopes to differentiate how they move through a magnetic field. We should know this one already. Okay. Density. Okay, so let's have a look. So density is the measure of mass per volume of an object. All right, so how heavy it is per the size of the object. Less dense materials will float on more dense materials, and alternatively, more dense materials will sink in less dense materials. All right, so there's a couple of ways to use density to separate stuff out. So number one is floculation. It's the process of collection of materials that float on the surface of a liquid. So here's an example. Right, so what happens is that they have a mixture inside this blue thingy here. Right, there's the mixture. What they do is that they pump bubbles in it, they spin it around, and what that causes is they create bubbles all on the surface. So those bubbles catch all of the stuff that's kind of floating around inside this mixture. And if the bubbles catch that and they bring it up to the surface, if you kind of design your thing in a way where it kind of stops the fluid from going, but the bubbles can kind of flow out, then you can catch whatever the bubbles have caught on it, and whatever the bubbles have caught on it is separated out from the original mixture. Now, if you want to collect those little things that attach to the bubbles, then you can collect those, and if you want to just get rid of them, then you collect the other part down inside the mixture. So that's the flotation process, right? Centrifuge is next. Right, so centrifuge is the process of placing a mixture in a circular path so that the more dense substances experience a larger centrifugal force, right, effectively the force pushing towards the outside, and thus move to the outside edge of the container. Right, so the most common example that you may know is the centrifugation of blood. Right, so you put it in this little device, it spins around, all the heavier blood particles end up at the bottom of the mixture. This one here is kind of a before, this one here is an after. Okay, so before it's all mixed up, but if after spinning, it ends up all at the bottom, and then you can either collect the clear stuff at the top, or you can collect all the bottom stuff at the bottom, depending on what you want to do your tests on. All right, another way to do this is pretty cool, right? If you have a mixture of two liquids, what you can do is you can spin it around. So you spin this container here, and as you spin it, the heavy parts of the liquid will go to the outside of the container. That's this part here and this part here. And the lighter bits will go into the inside of the container, right? Which is, well, this part here and this part here. Okay, so the heavier parts, if you design your device properly, can be collected because you're collecting from the outside of the container. You're collecting from the outside of the container. And if you're trying to collect from the inside of the container using a little bit of fancy design, right, you can collect the inside part. And thus you can separate the heavy part from the light part by spinning it around, right? And there's another little picture of it there. Okay, so that's pretty cool. Don't even know what industry does that, but that's how it would work. Cool. Right. Next, density. So, oh, that's still density. All right. So, what are we doing? We're doing separation funnels. Okay. So, a separation funnel is a device that can separate two liquids of different densities by allowing the more dense liquid to flow out of the device first. So, this is a separating funnel. You drop all the stuff into it. Right. So, stuff goes in. You allow it to settle. So, this might be the water. This might be the oil floating on the water. You open up your tap here, and all the water will flow out, right? And then you can close the tap when you get to the interface of the oil and water, and then kind of separate out the oil from the water, right? So that's just the separation funnel, which allows you to collect the more dense liquid, right? Come back. All right. Next is decantation. Okay, so decantation is the process of carefully removing the liquid from a settled suspension and leaving the sediment behind. Okay, so what's that? So here's this one. Here is your sediment. That's this stuff over here. Sediment, it's the stuff that falls to the bottom of your suspension after you let it sit for a while. So think like sand in water, that kind of stuff. Then if you carefully pour this out, right, you'll be able to get only the liquid and leave the sediment there, right? Same would be like if you're pouring out your soup from your noodles or your pasta, water from your pasta, right? That would be decanting, right? And then lastly is flocculation, right? So flocculation, let's have a look. Okay, flocculation is the process of adding substances that will cause all the small particles in a suspension, which are floating around, to clump together and thus increase their density so that they will sink to the bottom of the mixture, and then it can be filtered or decanted out of the mixture. So effectively, you've got a whole bunch of stuff floating around that inside your solution that you don't want it to be floating around. Okay, so what you do is you add your fancy coagulant, and then your coagulant or your flocculant grabs all of those impurities and makes them stick together. Because they are now heavier, because you brought them all together, they'll go settle down to the bottom, and then you can remove it however you feel like. Right? So that's flocculation. Boiling point now. Boiling point. There's a couple of ways to do this. First one is distillation. It's the process of boiling a mixture of liquids. If you boil it, so that's this mixture here, the liquid with the lower boiling point turns into a gas. Okay, so whatever has the lowest boiling point turns into a gas first, which is then collected. So see, the gas, the steam that goes out is collected in here and then forced to condense back into a liquid, thus separated from the original mixture. Right, so the gas goes up, right? After it hits here, it's got nowhere else to go, so it goes down this way. What this 7, 6, and 5 part is a condenser. It's a Liebig condenser. What happens is that you run cold water through it, and the cold water takes away heat from the gas, and it turns into a liquid. When it turns into a liquid, it'll drop through here, and then you can collect that cooler or the liquid with the lower boiling point separated from the mixture. Right? That is how distillation works. All right. Evaporation, okay, is the process of boiling off the solvent, which is the liquid that dissolves the solid, and then collecting the solute, which is the solid that's once the solvent has been removed, or so whatever remains. So if you think about this one here, if you were to say get some salt water and heat it up in your evaporating bowl, what would leave? This would be all the water leaving, and eventually you'd have enough water leaving that you would leave the salt particles at the bottom as a nice dry thing. Okay, so you're just removing the solvent from the solution. All right, so that is boiling point, distillation, and evaporation. Then finally we have the next one, fractional distillation. So fractional distillation is very similar to distilling. It's the process of distilling, but many components are brought above their boiling point, so a mixture of particles in gaseous form is collected. So if we compare this to normal distillation, distillation is that you heat things up, and then whatever is the first thing, or whatever is the lowest boiling point, is collected, And then once all of that's collected, you can do it again. You can heat it up again, and then the next substance will be collected. But you are kind of doing it one at a time, and you're heating it up from cool to hot, and then collecting it one at a time as you boil it. All right. Fractional distillation is a bit different. You make it super duper hot so that all of the components turn into gases. All of the components turn into gases. If all of the components turns to gas, then it's sent through a distillation tower. The mixture is sent through a distillation tower, which gets progressively cooler as it rises. Okay, so over here is the fractionating tower. You superheat this crude oil, which is the mixture. You superheat it. It gets super duper duper hot, and it comes out here. And then this is the hot gas down the bottom. Okay, so the hot gas goes down the bottom. And if you look at this thing here, it's designed in a certain way. So let's have a look. Right. So the gas comes in, right, or the mixture of gases come in, right, and you'll notice that it doesn't have, well, it can go over this way or this way, right, and generally if it's not hot enough even to melt it after that, like liquid bits and pieces will come down here and go that way. But as it goes up the thing, these little things here are little caps over holes. So when it comes up here, it goes, lifts up that cap a bit, right? Lifts up that cap and then goes out, right? What that does is that it forces, because what's happening is that those caps don't allow fluid to flow back downwards, right? So it has to go through this fluid as a bubble. So it's like bubble, 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 bubble. And then if it's still a gas, it can come out here, right? If this area of the fractionating tower, which is around about the same temperature, is cool enough, it will turn into the liquid particles here, which can be collected out through these parts here. All right, so the idea is that it has to be bubbled through that solution, which cools it down even more. And if it stays as a liquid, it will stay with that group of substances. If it stays as a gas because it's still above its boiling point, it will go to the next level, and so on and so forth. Right, we can even go this way and so on and so forth. Right, so it continues up and it gets cooler and cooler and cooler, and more bits and pieces start to condense, and then more of the stuff can be condensed and turned into their component ions because they're collected at those points. So it's effectively heat all the parts of a mixture up to super hot. As it cools down, the one with the highest boiling point will condense first, up in that at the bottom of the condensing tower or the fractionating tower. Then the next highest boiling point, then the next highest boiling point. Sorry, the next lower boiling point, then the next lower boiling point, then the next lower boiling point. Going up will be collected, right? So it relies on the idea that this gets cooler as you go up, right? And then it's collected in the bits and pieces. So let's have a look. The particles with the highest boiling point condense first, collected at the lowest levels. The particles with the lower boiling points continue up the tower, then progressively collected by condensation at various levels depending on how cool it is. That way you can separate many liquids at once. That's all about efficiency. Okay, and then finally solubility. Okay, so if you have a mixture, what color am I have done? I don't know, green. If you have a mixture of two solids with different solubilities, you can dissolve one of the solids, then because it is dissolved, you can filter out the other solid. So if you think of a mixture of something like sand and salt, that's a mixture of two solids, okay, mixture of two solids. One of them, the sand, is insoluble in water, but the salt is soluble in water. So you dump a whole bunch of water in, the sand stays as sand, and the salt dissolves into the water. You can then filter out the sand, allowing the salt water to go through. And then once you have the salt water gone through, you can evaporate out the solid out of the solvent. Right, so you just get rid of all the water by evaporation, and you've separated out sand and salt. Another way of separating by solubility is by chromatography, which is a process where different substances dissolve at different rates through a column and then thus separate. Okay, so you see here, maybe you've seen this in, I don't know, like year 7 or year 8 or something. You have black ink, and then it's made up of many different inks. They dissolve at different rates. The ones that dissolve the best and the fastest go further up the paper. The ones that don't dissolve very well end up at the bottom of the paper. Okay, and that is chromatography, which we will be learning much more about later on this year. Okay, so more information to process later. But that's it for separation techniques. Make sure that you keep on watching. Adios.